Hey everyone, mic check. Okay, super excited to be here. Thank you everyone for being here as well. Everyone's excited to kind of hear a lot about kind of the latest things that we, as well as a lot of the other people here, are working on. Today, I want to talk about verifiability for AI and give kind of a introduction to why we're building towards this thesis and why it matters in the world. Before I get started, a little bit about myself. I'm Matthew, one of the co-founders of OpenGradient. Before I founded OpenGradient, my background was in research engineering, specifically as a ML engineer working on models for options market making. So this is in TradFi in New York City. And before that, I had spent a good deal of time building software, mostly focusing on machine learning models as well as infrastructure for different tech companies in the US. And I met my co-founder, Adam, in New York. He was previously an AI tech lead at Palantir, where he spent close to 7 years building infrastructure for AI agents. And I found his work to be fascinating. He has personally been on many of the patents that Palantir has released, and a lot of his software and products that he'd worked on are actually used as AI agents in military and defense. And today we've assembled a team of 10 to 15 people who are very, very excited about the mission we're building towards. Today, most people have seen AI dominate news headlines. You see AI potentially taking people's jobs, companies laying off people, AI getting smarter and smarter, hacking and exploiting day one vulnerabilities, and more. Anthropic has also released a report showing that AI actually has a lot of potential in taking over and replacing employees across a wide variety of different industries. Now that AI has actually been deeply entrenched and increasingly ingrained in our daily lives, we think that it's critical that as AI makes increasingly critical business decisions and deals with more personal user data, that we actually have guardrails directly on the infrastructure and hardware side of things, as well as on the middleware side of things, to ensure that AI is behaving as we expect it to. And that's, from a high level, why verifiability matters, right? When you tell an AI agent to go and write a research report for you, you want to have some guarantee that it's using the correct model, that the right data is being passed into the AI agent to generate the expected outputs that you want. Without verifiability, it's difficult to achieve that. And the way I generally like to explain it is if you send someone USDC on the Ethereum blockchain, all the nodes on the network are able to verify that, hey, address A sent 10 USDC to address B at this specific time, and it was validated by all the validator nodes on this block and included. Similarly, we are building infrastructure that allows for this primitive to exist. We want to make it easy for people and developers and users to validate that the right data was, again, passed into the right program or model to generate the expected output. And the downstream implications of that are plentiful. As an example, people talk about AI agents working with each other all the time and coordination. An AI agent that might serve as your accountant might need your financial records and might need to request that from an AI portfolio manager agent. Well, to do that, it needs to be able to actually verify that it's retrieving the right data from the right sources and verify the actual tool calls and the actual data that it retrieves. Verifiability is important for that because you want to be able to actually audit the receipts, actually audit the sources to verify that the coordination and the transaction that goes on between these two agents is done correctly. Similarly, integrity is very important as well. If I tell you, hey, I have a research agent built on Claude Opus 4.6 and I'm charging $1 per X million tokens, I could easily swap that out for Haiku or a cheaper model and cheap out on you, and you wouldn't actually be able to know that or verify that. We want to be able to build these primitives to ensure that, again, the compute is done as expected and as advertised. And more importantly, when it comes to user data, your AI agents might be doing things like diagnosing illnesses or disorders in the future. It's important that your data is kept private and not stored on some OpenAI or centralized server that Anthropic owns, subject to subpoena by the government whenever possible. And many hardware and computing primitives, such as trusted execution environments, can actually ensure that your data is kept completely private and confidential, as to that you own your data completely end-to-end and that nobody else can access that data. There are many different exciting teams that are building towards this shared thesis and this shared future. Two I wanted to highlight. Firstly, one is Near, which I'm sure everyone is very familiar with. They have been pioneering their TE, Verifiable and Confidential Compute Cloud, which, like I mentioned earlier, brings you all of these benefits when it comes to computing. And they've also shipped Ironclaw, which is their open cloud competitor. And that's important for the reasons I outlined above previously as well. Ensuring that your credentials and your data are kept private. And as AI gets more and more entrenched in our lives, it's going to become, increasingly, it's going to deal with increasingly more personalized data, and we need verifiable confidential compute to keep that secure. Secondly is EigenLayer, which also is doing something similar, where they have verifiable confidential computing enclaves that allow these AI agents to leverage your credentials, like your bank account numbers, your potentially sensitive, other credentials, to leverage that in a secure and private way to do any actions on your behalf. We're building towards this same thesis, and we've engineered our infrastructure and our software from the ground up in order to reimagine how this can be done. On the very bottom layer, we have our infrastructure, which is a network of GPUs as well as trusted execution environment nodes that are designed to do the heavy lifting, such as the inference. On top of that, we have the execution layer, which is a EVM-compatible blockchain of full nodes that are able to validate and prove the work done by the infrastructure layer, and also serves as a smart contract endpoint for developers. Thirdly, on top of the execution layer, we have the model hub, which I'll show some screenshots of later, where you have essentially a decentralized platform similar to Hugging Face, where people can store, upload, version, or access different types of models that they might want to use on this developer platform. And of course, at the very top, we have research and tooling, including our Python SDK, as well as block explorers and other tools that make it super easy for developers to access all of this technology. And on top of that, we ourselves have also developed many models from the ground up to accelerate many of the AI and ML use cases within Web3. So this is a simple breakdown, high-level overview of kind of how we achieve, heavy compute directly within our blockchain infrastructure. The easiest way to explain it is we do something called node specialization. So like I mentioned earlier, we have a separate network of GPUs and TEs that are designed to do this compute, and all the validation is done on the blockchain layer, which is very, very cheap, right? So we have subnetwork number one doing all the proof generation, and subnetwork number two, which is the decentralized blockchain nodes doing the validation. And all of this, all the transactions that are sent to the blockchain network will only be included in the block if the proofs as well as the attestations are fully validated. We also have a variety of different features that we have built into our network, including TLS security, so things such as API calls, as well as network access that might be used in agent tool calls, as an example, can also be fully validated and verified. This is just a high-level diagram of what a simple transaction flow is. Not going to dive too deep into this, but we have essentially engineered this separate mempool and all this fancy tech to actually make it super seamless for developers to inference and call a model directly from a smart contract in Solidity. This is a screenshot, and again, it is our live model hub at hub.opengradient.ai. Today we have I think we have 4,000-ish models instead of 300. It's an outdated screenshot, but we have many different sorts of models that I'll highlight. We have models that we've engineered specifically, models for dynamic fees, spot and vol forecasting. We also host models that many of our partner protocols and teams have developed. Lastly, we also have a vibrant indie developer community where people build all sorts of different exciting models that they are interested in using. And we've also hosted different datathons and model-thons for people to contribute models onto our model hub directly. So models that I'm personally excited by that I wanted to highlight. Firstly, we host partner protocol models, including Filecoin's miner rating model. So this is a model that they use to actually rate how good a miner is performing on the Filecoin network. We have also worked with Uniswap, and this is one of our earlier models, to build vol forecasting style models to dynamically adjust AMM fee parameters in order to reduce net impermanent loss for users. We also have developed different spot forecasting models, like this one as an example for Bitcoin. And lastly, also host more traditional AI models, including this LLM that Sentient has released, which I believe is just RL on Llama, but very, very unhinged. And again, we have a very wide assortment of different models on our hub, and aim to make it as easy as possible for developers to directly go access these models, fine tune them or create different versions of them and use them for their own developer purposes. And the downstream kind of effect of having all of the infrastructure, the blockchain, and the tooling that I mentioned is we can now develop protocols that are secure, verifiable, and now smarter, right? Given that they're empowered by these different models. A couple different use cases and case studies that I'd like to highlight. Firstly is we actually ran a simulation long running with the models I spoke of for AMM dynamic fee adjustment. And you can see that with dynamic fees, the machine learning model that we embedded directly into a Uniswap v4 style AMM, you can actually see up to 16 to 17% of reduced impermanent loss for LPs in these pools. Similarly, Repo, which is a spin-out from Filecoin, leveraged the Filecoin rating model in order to create new tooling and new primitives for Filecoin node runners, as well as validators and the foundation themselves, where they can actually evaluate which miner nodes are the most reliable, which miner nodes are less reliable, and this way they can distribute incentives and emissions for their tokens accordingly based off of the performance. The last one I'd like to highlight is a more interesting one that we do. So we partnered with Double Up, which is a prediction market casino style protocol on Sui network. So we put our spot forecasting models against their users, and people can bet against the model when it comes to forecasting the prices. And that was an interesting study where we showed that ML models can significantly outperform human intuition when it comes to forecasting prices, and can be apparently a source of revenue and traffic for even protocols not even adjacent to AI, such as casino, gamble-fi prediction markets. On top of building all this tooling, infrastructure, models, we've also developed some exciting ecosystem applications that are completely end-to-end homegrown. One of them is BigQuant. And again, the ecosystem apps that we build here are designed to showcase what verifiable AI can do and what the downstream applications are. What BigQuant is it's a personal crypto portfolio manager that you can connect your wallet to. You can directly ask it to swap assets for you on a wide variety of different integrated protocols. You can also ask it to analyze the market, and it taps into all the different machine learning models that we have on our network as tools. And it can tell you, as an example, what the risk levels, of your current portfolio holdings are, what the expected return is based off of historical returns. It can even run simple simulations, as well as give you an assessment of what you should do and recommendations for how to rebalance your portfolio moving forward. And again, this is all enabled by verifiability, because if we didn't have a way to actually audit and secure agent actions, the agent can be manipulated to do all sorts of things, and you would be none the wiser. You would not be able to actually verify that it's doing the correct actions. Secondly is one that I found to be pretty exciting. With confidential compute, you can actually now leverage these new exciting ways to deal with personal user data. One we built was MemSync, where users can aggregate their digital footprint, so their data from Twitter, their data from Reddit, personal websites, podcasts, videos, and ingests all this data and turns it into your personal memory database. And now this personal memory database can then be used directly in AI applications. So you can connect it to ChatGPT or our MemSync platform, and you can talk to AI that immediately understands you, your personality, your interests on day one. And this makes it, of course, or this is uniquely enabled by the TE nodes that we have on our network, because all your data is computed directly within the confidential enclave, the turning of your data into vector embeddings to ensure that nobody but you has access to that data. We've also engineered our own memory infrastructure from the ground up, and at some point last year, we were state-of-the-art on long-term conversation memory benchmarks, such as Locomo. And on top of MemSync, we then built a more fun consumer use case, which is digital twins. When you have access to all of your personal data in the form of this personal memory database, you can then create AI agents that have access to that to create digital representations of you, how you speak, how you think. And we spun up a protocol that allows people to create their own digital twins and allow people to buy shares of those digital twins in order to interact with it. Of course, we also embedded a lot of security features such as systematic PII, personal sensitive data redaction, and ultimately, it was an exciting use case that we wanted to build towards. It's use cases like this that showcase how AI can be leveraged in unique ways with verifiability. We can now build these personalized, curated agents that have access to niche knowledge, expertise, skills that individuals have to emulate the way people think, the way people talk, and the way people might act and execute in the future as well. So this is something that we're continuing to develop and are pretty excited about. And yeah, it's been an exciting journey seeing people launch a lot of their own digital twins. And in addition to the 3 ecosystem apps we've homegrown, as well as a lot of the other apps that we have worked with and developed, there are many downstream use cases that ultimately are uniquely enabled by verifiability and security that networks like OpenGradient bring. As an example, one we're looking into is how AI can be used to verifiably resolve arbitrary or gray area prediction markets that might have ambiguous resolutions. So you can now have prediction markets such as, hey, was Trump rude to Takaichi, the Japanese PM, in their press release or interview? Prediction markets like that, you can rely on an AI agent that is able to query for all the data and verifiably come to a deterministic response. And this removes the potential for people to manipulate the oracle, which has happened on big prediction markets like Polymarket many times. And in addition to that, of course, we have many other exciting use cases, mostly embedding ML and AI directly into on-chain protocols for more intelligence that is also secure. Our vision is ultimately to make AI actually secure and verifiable and also keep user data confidential. AI is getting smarter and smarter and is making more and more decisions for people on the daily. It's important that we build the verifiability directly into the computation in order to make sure that AI is secure. Even if AI is smart, you wouldn't want to trust it with your personal data. You wouldn't want to trust it with business critical decisions if you know that the operator, on the other hand, can easily manipulate or exploit you based off of what you're using it for. And this attack surface area is only going to increase as the usage of AI increases. And we've seen empirically that has been very much so on the rise. We're also excited to announce that we will be launching OPG, which is a token that essentially secures everything on the OpenGradient network. If nodes generate faulty proofs, as an example, or attestations that are invalid, they will be slashed. And this gives you guarantee that you will get the right proofs and the right compute will be done. We will also be using that to reward model developers who contribute continuously to our model hub and add more models that people want to use. And lastly, of course, the token will also be used for compute payment and usage. If you want access to verifiable compute on our network, you will pay and transact in the token to the operators and compute providers on the network. We're excited to have assembled a team of 10 to 12 people now to build towards this mission, and hope you enjoy these AI-generated profile pictures of us wearing shades. But we come from many different parts of the industry. Like I mentioned, I personally come from 2 Sigma in quant finance. My co-founder comes from Palantir in AI. Many of our engineers come from great places like Google, Facebook, Capital One, so on and so forth. And again, we're very excited to be building towards the next era of AI, which is not AI that is just smart, but AI that you can trust, AI that you can ensure will not do anything to with your data, AI that actually does what it says at the end of the day in order to unlock these downstream use cases that can do more. And thank you so much. Very, very excited to talk more about the mission that we're building towards. We have been shipping relentlessly for a year or two now, and very excited to share more updates that will come in the coming weeks and months. And thank you so much.